Hi there, students. I wanted to show you that you can do an ANOVA statistical test and a t-test using your Excel spreadsheet program on your MacBook Airs. Now to do this, you first have to make sure you've installed an add-in, and it's actually just clicking a button. It's really easy. I'm going to do an ANOVA test on this project right here to see if the results are statistically significant. So as you can see, it's the final heights of radish plants after 2 weeks of growth. So if you can see here, we've done pH 3, pH 5, pH 7. Here are the plants and their measurements. We've also calculated a mean and a standard deviation. You can see that it appears the pH 7 did really well and the other two were very close. There's a lot of variation and a lot of overlap between these two, but not so much between the pH 7 and pH 5. But an ANOVA test is what you do to see if these are statistically significant differences. So in order to do that, you have to install an analysis pack. So if you're on your home page here and you've opened up an Excel spreadsheet, in order to install the analysis pack, you need to go on the gray bar to the word Tools and then go down to Excel Add-ins. So Tools, Excel Add-ins. Then you have to make sure that this button is marked, is checked, Analysis Tool Pack. I believe yours might say ATP. I'm not quite sure why the teacher version has this. Maybe we have a bigger screen. Some of my students told me that instead of Analysis Tool Pack, it says ATP. Make sure that's checked and you say OK. Then what you do is when you go to the green bar here where it says Data, and you click on Data, you will see a Data Analysis button here, and that's what you need. Okay, so we're going to do an ANOVA test. So first of all, I'm going to do an ANOVA. If I click on a data analysis, the very first test is the ANOVA single factor. We say OK for that. All right, now we need to click the range that we're doing. So what we're going to do is we're going to make sure that we doing these three columns and just the data. Notice I'm not selecting the mean or the standard deviation. That's the input range. I said it's grouped by columns because my data goes down, like pH 3. These are all the pH 3, pH 5, pH 7. We're not going to do this way. If I had pH 3, pH 5, pH 7 here and was going this way, then I would do by rows. But this is grouped by columns. New workbook, and you're going to say OK. All right. And there you go. It's calculated for you without putting it in your calculator. It's already in your spreadsheet. What you're interested in is this p-value. This p-value has to be less than 0.05 to be able to reject your null hypothesis and say that there's a statistically significant difference between the means. P-value has to be less than 1. So be careful. If you see where it says e to the negative ninth, that means times 10 to the negative ninth. So this is 6.8 times 10 to the negative ninth. That is much less than 0.05, which means there is a statistically significant difference within the means, and you can reject your null hypothesis. Well, that makes sense because 4.8 with that variation, that standard deviation, doesn't overlap at all with 1.7 or 1.8. So you can say, first of all, that your ANOVA test was significant, that your means are statistically significantly different, and you can reject your null hypothesis. However, ANOVA test just tells you that there is at least one comparison among these groups that is significant. It doesn't tell you that they're all significant. It tells you that at least one or more are. So I suspect that this 4.8 and this 1.8 and 1.7 are different, but I'm not so sure about 1.8 and 1.7. So this is where you do a t-test, a comparison between two groups. Again, you can use the data analysis pack. Go to data analysis. Go to t-test, and we're going to do two sample assuming equal variances. Okay, so data analysis, t-test, two sample assuming equal variances. We say OK. And then we have to select the data that we want to use. So the variable range 1 that we're going to use is the pH 3. Okay, just the data. And the variable range 2 is variable range 2 is going to be pH 5. Okay. And we're going to just use 0.05, new workbook. We're not going to hypothesize a mean difference. We're just going to say OK. All right. Now, you'll notice that you have two p-values. One here that says one-tailed. If you kind of move this out a little bit, you'll see it says one-tail, and you see the other that says two-tail. The statistics teacher said we should use two-tail. So if you look at two-tail, it's 0.847, okay? And use two-tail because you're just saying there will be some difference. She says the more conservative one, so it's the one to use. So it's 0.84. That is not less than 0.05. That comparison is definitely not significant. So if we go back to the sheet, we can say, well, there is a difference, and likely it's between the 4.8 and these. But these two groups, pH 3 and pH 5, are not statistically different. So while pH 7 did better, pH 3 and 5 did worse, but not from each other. Now, just to verify this, we can do the pH 7 versus the next closest group, which is pH 3, to see if that's statistically different. I suspect it will be. Let's see. Let's see if it's less than 0.05. So go again to data analysis, to sample. This time we're going to use the pH 3, but for the second range, we will use the pH 7. So I'll select the pH 7, and I'll say OK. And this time, if you look at the two-tail, again, let's move this out so we can see it. It is 2.07 times 10 to the negative 7th. So in other words, it is definitely significant. That's definitely less than 0.05. So that comparison is significant. So if you were then going to draw some conclusions, statistically speaking, from this data, you would say essentially that you can reject your null hypothesis, at least in part. There was a statistically significant difference between the neutral pH 7 plants and ones that were acidic, pH 3 and pH 5. So you can reject the null hypothesis. However, between pH 3 and pH 5 themselves, you cannot reject the null hypothesis. There's no statistical difference between pH 3 and pH 5. They were equally harmful to the plants. So that's your little tutorial on doing putting your analysis tool pack on your Excel and then doing the ANOVA NT test.